Hi everyone, my name is Joshua St. Germain. I'm going to talk about data mining for this technical presentation. So we've talked a little bit about data mining and big data in this class, and I want to go more in depth with it because I really appreciate it. And I really think it's kind of fun, and I think it's a big part of our future. For those of you who don't know where data mining might be used, every time you use Google Maps, every time you talk to Alexa, Google Home, or um, do anything almost on Facebook or even at the grocery store when you buy items. You're all your data is being stored somewhere. Now, the important thing to understand is this is happening pretty much everywhere. Um, Anytime you buy something, anytime you talk into your phone, anytime you type a message out, it's potentially could be stored somewhere. Now, there's obviously legal and privacy issues regarding all this stuff, but we'll talk about that a little bit later. More importantly, we have to find out what is data mining actually. So at the most basic level, data mining is finding patterns in data and analyzing those patterns, and then, more importantly, predicting future patterns. So when we want to do something, we look at data and we go, all right, based on this current data, where do we go from here? So obviously data mining is being used in many industries, business included, especially marketing and things like that, where they want to find customers or they want to find out where the markets are trending or anything like that. Manufacturing technologies, where we see things like trying to improve processes and trying to improve industrial engineering processes to make cheaper, better materials and products. So you might be wondering, well, how do we start? What do we do to get from raw data to something that's usable, something that we can, show our boss, show somebody, and go, look at this data. Look here, I found something important. So there's basically 5 steps. Uh, as you can see, so we take raw data. You have to find a source for the data. Once you find the source, you can clean and scrub it and get all the dirty data out. Then you have to explore data and understand what you're seeing. You create a model and then test and utilize that model in your business or whatever it may be. And then you can always go back and change your model. It's more of an iterative approach. Data is always changing. There is always going to be new models and new things to study. We'll talk about that a little bit more later. So the first step is obviously finding data sources. So as you see this little picture here, we have lots of data sources. Twitter's a big one. Facebook's a big one. Google has so much data on us. But every time you log in, they have data. They have data on everything, cookies, whatever it may be. Skype, like all these sources. So the important thing to figure out is, okay, what are we trying to figure out? What do we want to know? What's the problem we're trying to solve? The big thing is you have your problem statement or your mission statement, whatever it is. You have to find data that's going to help you support this, and it might be something from Twitter. If you're okay, we need to figure out how big is this news story to people. Okay, well, people are tweeting about it right now. Let's go, pull some tweets from Twitter. Let's pull data from Twitter, or what are people clicking on Facebook? What are the ads what ads do we need to tailor for them? So we need to go find data from this group of people or this area of the country. And probably now we come to the most tedious and least fun part of data mining and data analysis, which is cleaning data. Okay, how do we get from dirty data to clean data? So this obviously can depend. It really depends on your source. So the better the source, the better the data generally. However, there's always things you don't need. You're not analyzing everything. That'd be impossible. You're not analyzing every click, every tweet. You're analyzing this subset of tweets at this subset of time or this subset of people. So the important thing is to get rid of anything extraneous. So as you see here, data that is incorrect, incomplete, improperly formatted, or duplicated. So if you're running a marketing campaign and you want to send out data or get data of people that are within the area and figure out, okay, we're targeting this marketing campaign at students who live in Tempe. So an important thing that you may have is you may have all this data from students, however it may be collected, but it might be so improperly formatted. All the addresses could be, just without commas or without spaces or something, and it's important to be able to go in there and clean it up so you can actually get the right data and all the necessary requirements for your problem-solving adventure here into data mining. You obviously don't want duplicates. There's really no reason, unless there is. Unless you really want to just have so much more data. And there's basically two ways to do this, which is manually or automatic. Now, it's pretty general I say that, but manually is obviously the worst way to do it, but sometimes it's the only way to do it. Sometimes data just has no pattern, or there's no algorithm that's going to safely do the data, and you're going to need to pay someone or do it yourself, where you are going to have someone go in there and actually scrub data. It's not fun. I've done it, and it's really, really tiresome and really tedious. Now, the better way is to do it automatically. On the right here, I have a little picture of just a basic Excel thing that you could use, which is get rid of a comma. Let's say you have something and you want to get rid of commas, like in this example. You don't need the commas if you're analyzing money, right? Money's money. This is how much it is. A comma would just be more of a problem when you're trying to analyze a number, because now makes it a string instead of an actual number. So when you're analyzing something like this, you need to get rid of commas or periods or anything of that sort. But that's a basic Excel, and there's way more algorithms. There's so many things, there's so many toolkits out there that help you actually data mine, and almost anything can be done automatically these days. We're at the point where we kind of understand how to do this a lot better than we did not too long ago. And then this is probably the most important step, is exploring your data. Like I said here, you want to tie in what you're trying to solve or accomplish. Remember that problem that you're trying to solve. What are we trying to show with this data? What do we want to know? And there's an incredible amount of methods to doing things like this. So I've listed a few of them here. There's plenty to look at. So I'm going to show a few pictures here of just basic things. All right, so this is, I'll kind of go over a few of these later, but I'll go over the more important ones, or more of the ones that are used more often. So clustering. Clustering is basically how it sounds. You cluster data based on how similar it is to one another, and you get to choose what that is, usually. So if you want to cluster something based on time of day something was tweeted, you can cluster around that. Or you can cluster by similar attributes. Okay, this many people bought Tide detergent during this time, so what else did they buy? What do people that buy Tide detergent usually buy with that? Classification. So when you look at data, you want to figure out, okay, what exactly is this thing? So you want to classify, all right, we want to classify this as something else, or however we want to classify it. So a good example, or just a basic example, is, okay, how do we classify a dog? A dog has 4 legs, it has fur, but what separates that from a cat? Do we want to classify a cat as a dog? No, but you have to figure out the right rules and the right things to ask when you're classifying this data. Patterns also pretty self-explanatory. Association, pretty important as well. Association is when you look at things that are associated with one another. So if you're buying something at a grocery store and they can look at, okay, someone who buys fruit is usually more likely to buy other healthier items, so maybe you'll give them coupons for something like that. There's a well-known example of this that kind of went awry. A few years ago, Target, I believe, was trying to was sending coupons to a girl, and all the coupons and stuff were related to babies, and what had happened was it made it look like she was pregnant, and the dad went to Target and said, "Why are you sending these coupons to my daughter? She's not pregnant. She doesn't have a baby." They said, "Oh, well, she's bought items that show that she might be pregnant." Turns out she was. So Target actually knew that this girl was pregnant before her father did. So This is kind of the importance of data mining. Is it can be super powerful when it needs to be. Prediction, it's also self-explanatory. You can just predict based on other things. Decision trees we're probably all pretty much familiar with, but if you're not, it's basically it's very similar to classification where you're saying, okay, is this thing over $4,000? Yes. Oh, okay. Do they have 2 children? Yes or no? And then you go from there until you get something that you like. Combinations are it it's used for nearest neighbor clustering and stuff like that. I won't go into too much detail, but it's also a pretty important technique. Next, I'm just going to show some. So this is a clustering algorithm. As you can see, they can be pretty fun. They're very colorful, but there's a few at the top. There's k-means, fuzzy k-means, and dbScan. And these are all just different algorithms to identify how similar clustering is. So you can see at the top, there's a k equals 2. That means you want 2 clusters. K equals 3 is 3 clusters. This is also your choice. With more experience, you can figure out, okay, well, how many clusters do we need? What's the best number of clusters? Because sometimes 3 is good, sometimes 2 is good, sometimes you need 10 clusters because the data is that different. But you can see that you could visualize it in different ways. Again, here's kind of one I was alluding to. This is a classification tree. It's very similar to a decision tree where you're saying, okay, is the income over $5,000? Okay, and then you go to the next step, and then the next step until you finally get to something which is, oh, purchaser, non-purchaser. This is how we're going to classify these 2 data, or this is how we're going to classify the data set into these 2 categories, purchaser, non-purchaser. And here's an association, a visualization, like I was kind of talking about earlier. Okay, if you buy a tropical fruit, you're probably more likely to get canned vegetables. If you're getting liquor, you're probably going to get canned beer and bottled water. Milk and cereal is very common to buy together. Who would have thought? Cheese, sausage, and spices. Okay, maybe they're making a pizza. There's things like this that the data can tell you that can help you drive your market or drive your business, things like that. Now you can go on to modeling. So eventually you get to a point where you can say, all right, the amount of people that buy Tide are going to definitely buy this at a 90% rate or something like that. Kind of like with the example before, we have, okay, people who have this much money and this many kids are going to be a purchaser. We need to target them. And once you have this, like I said, there's no perfect model. There's never a perfect model. Things are just going to happen. There's always outliers in data. There's always things that can go wrong. Predictions are not always correct. And that's the beauty of these models is you can change them whenever you want, pretty much. As long as you can show that the data is important and there's reason and there's actual mathematical reason to drive all this, then the models can change as long as you want it to. Because then you might be asking, all right, so someone who may not be versed in data, or someone like your boss, if you're trying to show your boss, or you're trying to show something, look, this data is meaningful. Look, how do we do it? Or how do you show someone who's maybe not technically versed, or maybe not the best at understanding this? Visualization is a huge part of data mining. When you want to visualize data, there's a whole bunch of ways to do it. Like I said, here's a little clustering one. It's pretty self-explanatory. You go, okay, these data points are very similar to one another. And then you can get into more cool things. So on the right, we have a sports graph where we see, okay, here's the most valuable teams. And they're arranged by color, and then the size of them is how much money they have, and how long they've existed, things like that. And then we have another one, which is this one obviously pulled from Twitter and went by Twitter mentions, and it's showing when was the peak Twitter. Okay, so we have the Ferguson shooting, the State of the Union, we have Clippers controversy. This is obviously done a while ago, 2014. But Ebola, election day. These huge spikes in tweets are obviously being driven by something, and this is what there was. It's Hobby Lobby, whatever, the Russian invading Crimea, whatever it was on that day. So visualization is very important, and showing that your data has meaning and that what you've been doing is meaningful. So data mining equals very important. We use data mining all the time, as I've kind of talked about. It's used in healthcare, marketing, manufacturing, all this stuff. Especially right now, the hot buzzword is machine learning and AI, and without data mining, most of the machine learning algorithms can't work, and neither can some artificial intelligence. There's so many possibilities. It can be used in practically any industry as long as I mean, they use it in sports all the time. Baseball uses it all the time. We need to find who's the most valuable guy. How do we crunch these numbers? What do we determine value is? How do we determine an unvaluable from a valuable player? Things like that. But here's a little machine learning kind of visualization that I saw, and it also kind of helps you understand data mining. So when you build your model, you need to throw training data at it to train the model to make sure it's actually outputting the right things and it can learn. So the more it has to train off of, the better it can learn. So the more data you put in over time, the better the models get. So more data equals better models. So as you can see, you can put the training data in, and then whatever the algorithm does, it can make a prediction, and then you evaluate whether, okay, did this model make the right prediction? Is it doing the right thing? Is my machine learning algorithm, is my AI doing what I want us to do? So things like Alexa are really big right now, where they analyze words and predict words and keep all that data stored, and they learn you better as you go on and keep using it. The more you use Alexa, the better it's going to be. And they're just going to keep making it better because the algorithms are just going to get better. Machine learning is just going to get better. So all these things, especially AI, are just going to get better with time. And sometimes data mining and using these models it's tough at first because you don't have enough data and maybe not doing the right thing. But with more time, with more data, things get better. Speaking of time, where do we go from here? What's the future of data mining? So I have three things here. We have multimedia data mining, which I think is really, really cool. Basically, instead of pulling just from text or things like that, we pull from audio. We pull from movies. There's a few cool visualizations I've seen where people pull how much or what colors are used most in these types of movies, or what colors used most in the scene, and they can pull the data from the picture and then show, okay, red's used in this angry scene, or blue's used in the sad scene a lot. So there's things like that we're kind of doing, but I think once we can get to like a full multimedia where we can just take almost any piece of media and mine it, that would be a very big jump in the data mining community. Distributed data mining, this is where you just basically put data mining or data in different places, and then you can mine from remote locations or things like that. It's not all in one centralized setting. Geographic data mining. So like I said, there's some industries that may not be using this too much right now, but will be. One of these places is geography or spatial, where we want to look at data regarding planets, or maybe we want to look at data regarding our own world, where we want to go, okay, well, what is this water made out of? What at this time of the year? What happens to the ocean? Things like that. Predictive analysis is probably the thing we're closest to, the biggest thing. And this kind of ties into Web 3.0, which is right below it. But we're going to get to a point, I think, where our models are going to be so good that they're going to know us probably better than we know us. And you've probably experienced this when you've been on Google. You see an ad for something that you didn't even look up, but you're like, oh, I was just thinking about that the other day. It's a little creepy, but it happens, right? So we're kind of getting to this point where the models are so good that they're predicting and they predict us, and eventually maybe we can get models that are so good at predicting other things. Maybe it's earthquakes, right? We tie that in with the geographic data before it. It gets so good at predicting earthquakes, we can move people before they even happen, or before a tsunami happens, before hurricanes happen. So I think that'd be a big jump if we can eventually get such a good predictive analysis. And then Web 3.0, if you don't know what this is more so something they're calling, I think, semantic web, which is basically where the web is kind of an extension of you and kind of a digital assistant where it knows what you want, it interacts with you, and it can predict what you want from the internet before you may know it, or it might predict based on the day. Every Tuesday you look at the standings for the basketball games or something, and it knows that before you even type it in. It can just pull it up when you sit down at your computer. So data mining is going to be very important to the Web 3.0 and the future of the internet. So like I said, data mining is really cool. It's really fun. It can be really difficult, but just if you want to get started, look up Python, look up things like that. There's plenty of toolkits out there to help you learn, and hopefully we can get to some of these cool things I've been talking about in this presentation. Thank you.